So we will open the workbench. We will do the analysis for a nozzle. First we will do ICM meshing in this video, and in the further video we will do the setup file. So just to open the ANSYS Workbench 2023 or whatever you have. So click on Fluid for Fluent under geometry. Right click on geometry. So you need to import the nozzle. So as I have already this design, so I imported this geometry. For your reference, if you want a nozzle, please comment on the section. So I'm just opening the nozzle over here. So for creating a nozzle, I have got already. So if you want to do this analysis, you can create by your own by doing a revolve in the geometry or in the SolidWorks, whatever you have. By doing a revolve option, you can create this nozzle. So first we will create the part one by one. Under ICM, click all the sites. By clicking all the sites in the part, you just retype as wall. So after clicking wall, click on apply. So you can able to see the structure. So you need to write the inlet and outlet on the left and right side respectively. So inlet on the left side and outlet on the right side by clicking the proper section. I type the outlet and apply. Okay, and then go to blocking. Click the first option. You can able to see create block. In the create block, you just click the create block, apply. No need to give any other things. The first option is getting over, and then the geometry in the second option. So you can able to see the wire like structure. So here you need to coordinate. So just click two circles and click on the middle button. So this is a very important thing. So you can able to see by clicking on the middle button, you can get a coincident. So create modify curve. Under create modify curve, you need to click the curve, and then clicking on both the curves, you can able to see by clicking the middle button, everything has been done. Then click continue. So this is a wireframe you can able to see. So under blocking, go to second option. Under split block, you can able to see there are so many options. So here points, you just click the points. It is suitable for us and it is very easy for us to do the simulation. So you can able to see by clicking on the mouse button as well. So you can able to see the isometric view for this. So click the prescribed point on the split method because we are going to split block over here one by one based on the points. So clicking blocking associations, in the second option edit association, click on the four sides and click on the circle and then click middle button. So this is the way you can able to see. I'm telling again, click on the four sides and click on the circle by clicking the control parallelly, then right click the middle button. So this is the way we need to do this. You can able to see the edge selection. So under edge selection, clicking the edge and the point, you can able to split. So this is splitting, you can able to see. So by clicking the edge and the point, you can able to split the block in the block way. So by this method, you have completed the splitting of block by going to the blocking associations. So under edit associations, you need to click all the four sides and on the center button. So everything has been associated. So this is association with the block with respect to the circle. So this option we have to do compulsory. So by clicking all the four sides and in the center circle, you can able to see it is created. So we need to click this circle as well. So by clicking all the four sides as well as the center circle and then click the middle button. So this is a way we need to do for all the circles, whatever you are applying over there. So this is very important process while you are applying in ICEM CFD. So half of the ICM has been done. So under go to project vertices, snap vertices, then click apply and OK. All visible. Under all visible, you can able to see. So under split block, you can able to see the many options. Under split block, you set the first option and click on all the blocks, whatever it is in the figure. So in the center we have missed one block, so I click on those blocks and click on the center button, middle button in the mouse. You can able to see the blocks whatever it has been appearing over here. So click on the front and inlet and outlet side, as well as the side whatever you are able to see. Side, it means it's a flow from the left side to the right side. You should not select the left side, so it is selecting the left hand side. You should not select it. So it is a selection of the center plane. You can able to see over here. So it's not coming over here. It's going left side. So you should select the proper. So right now it's came. So it is going. So it is very critical process while you are giving this application. While doing the ICM process for this one, it is very little bit difficult for you. So you don't need to worry for this. You just click on the center plane, whatever you are doing over here. So I'm just zooming over here, and then you can able to see the center plane. So now also we are not getting. So in the center plane itself, the task is to get the center plane is very complex for us. By clicking this center button, you can able to see. So I'm just moving, zooming out. So it's little bit difficult process. I'm just going from first step onwards, like splitting the blocks and clicking on the center button and go to select faces. In the select faces, we need to select all the faces from left and right hand side one by one. So now it's coming. Yeah, that's it. So we have completed this face selection. So this is a very difficult task, and click on the middle button. The same process what we have done in the previous videos as well. So ICM is a very little bit difficult when you are doing the first time. So we have done the overgrid as well. So pre-mesh params set on the third option. So here we need to give the number of nodes, how much it is required for us. So this is very difficult thing. Number of nodes is 20, and then spacing is 0.0001. So for a better boundary purpose. So you can able to see the pre-mesh params, the copy parameters to all the parallel edges. So we no need to give the number of nodes parallelly one by one. So it is very useful option for us doing ICEM CFD. After clicking 20, you can able to see all the parallel lines has been given, updated as a 20 number of nodes. And click apply and click on the middle button, you can able to see. So again, we need to give the 20 for this Z direction. And for Y direction also, just click the 50, the suitable number of nodes, whatever it has been recorded for us. So for an X direction, you just click 100. So likewise, we need to give the number of nodes, whatever it has been suitable for us to do a better fine meshing. That is very useful for us. So for decline the line, you can able to see the 20 I'm giving. So depending upon your need, you just click the number of nodes. If you want 30, you can give 30. I'm just giving 20 for all the lines. If it is a huge line, I'm just giving 100 and 200 like that. So it is very useful for you to do. Almost 90% of ICM has been completed. So if you give pre-mesh, just give yes. So mesh has been completed. You can able to see in the overgrid structure. So depending upon our nodes, if we give the surface, and this will be full solid. So this is a video for you. So at the end, we need to give the save option. I hope this video is useful for you. For more information, subscribe, like, and share this channel. So it will makes me more motivated to post more amount of videos. So here inlet, pressure inlet, so outlet, we need to give whatever the process we are doing, depending upon the work we need to give. So in outlet I gave a pressure outlet. So we have done the simulation, we have done the ICM CFD through ANSYS.